Hi, everyone. My name is Kenneth Ford. I'm a developer advocate here at Google, working on Android apps on Chrome OS, foldables, and other larger screen devices. In this session, we're going to talk about bringing your app beyond just the mobile phone and the things that you can do. Specifically talking about tablets, foldables, as well as Chrome OS and other desktop environments. So some of the major differences on these devices than your normal mobile phones is the screens are just much larger, and your users are going to want to take advantage of this when they use your app on these devices. You'll also see that people are using these devices in very different contexts. They'll be using these devices for much longer periods and much deeper times in each application versus a phone that's maybe a much quicker kind of pull the device out, get something done really quick, and then move on. A lot of times for tablets and Chrome OS and desktop environments, especially, they'll be a lot less on the go. They'll be wanting to get more done and have like deeper experiences in each app. So let's look at an overview of what we're going to talk today. We're going to talk a little bit about app continuity and what that means for your application. Some UX UI considerations when thinking about bringing your app to these devices. Multi-window and some of the challenges and things to think about. Input changes and some of the kind of different input mediums that are used, and finishing off a bit with some of the emulator tools that are being released. So what is app continuity? App continuity is the idea of the app continuing when a user unfolds or folds the device. And this also follows to other configuration changes such as orientation and window size changes. Things like scroll position, video playback timestamps, text that the user has entered should all continue as if nothing happened. Configuration changes, while something that we know that apps have ran away from in the past, you can't really avoid them anymore due to the devices actually just changing states versus being able to just lock orientation or lock resizability. But this concept is not just a problem on foldables. Chrome OS has a native freeform windowing system, as well as tablets and other larger screen devices are shipping with freeform windows natively. Resizing has the same challenges as folding and unfolding in that you'll run into configuration changes and window size changes. Multi-window is used much more on these devices as well, at least speaking with tablets, whereas on Chrome OS and other desktop environments, it's actually the native use case. And we've seen studies that show that people want to use apps in multi-window more as the devices get larger. Seen as a use case that wasn't used very often on smaller phones, these devices are really kind of showcasing both the great things of apps in multi-window as well as some of the challenges. So these changes should be seamless to the user. When they open or close their device or resize their window, they shouldn't be confused or shocked about what happened in the application they're using. Or even in some of the worst cases, we're seeing apps that reset the user all the way back to the starting screen of the application. You should be supporting different window sizes and orientations. While with a phone, most people generally use their app in full screen and in portrait, some of these devices are landscape first, as well as just having a much higher usage in landscape compared to a phone. Some of the foldables also with their different aspect ratios and being closer to 1:1, you'll see people using the devices in landscape much higher because it's not that different of a screen setup. Now, you can use layout tags to keep your windows in a range that you support if you feel like this is an issue. And this is the better solution than just locking to full screen and being non-resizable. You should handle screen size changes gracefully. Now, this isn't just saving state or saving video playback time. You should also be laying out things smoothly without a ton of jank. The OS can handle your relayouts fine if you are letting the OS handle things during configuration changes. But if you do feel like you need to do things manually in your views, one of the approaches that we've seen work really well with partners is to have your views just subscribe to some type of global object that you have that's reacting to these window size changes and passing those directly to the views. So let's talk a bit about some of the UX and UI considerations that you have to think about when bringing your app to these different devices. The first is some of the devices just natively are a different aspect ratio from what you're probably used to supporting. Some of the devices are as extreme as 21:9, as well as closest to 1:1. And this is just not the traditional kind of phone screen size that you're used to. On top of that, freeform windows allow you to be in almost any window size or aspect ratio. The min-max aspect ratio tags in your manifest allow you to limit the barriers that which you feel like your app best performs. And again, this is recommended to just locking as non-resizable. The other thing to think about is that certain navigation patterns don't always work best for every size. Specifically, bottom navigation does not stretch super well when the window size gets very wide. Let's look at the material study OWL and see kind of how they handle this. So on a phone, bottom navigation looks and works really well. It's easy to access by the user on a phone device with whatever hand they're using. But when they get to a wider desktop screen, they move it to a navigation rail so that users can handle it and access it with their hands, as well as just being in a more native location that they're probably expecting. People are used to left side navs on these bigger devices, as well as on a tablet, it's very close to their hands, whereas a bottom nav would be very stretched out across the bottom of the screen and would be very hard to hit items in the middle. The navigation rail spec has been posted on the Material website, so you should check it out and see if this is something that you could bring into your app, and the Android component is currently in progress. You should also think about how you can adjust your layouts for these larger windows and larger screens. Think about how your content should scale, and really think about how you can bring columns into these layouts. One of the things that we notice is a lot of times content just gets scaled across the entire display, and it becomes more of like a layer cake design, which works really well on phones, but doesn't necessarily scale when the devices and windows get very large. A couple things that you can think about, as well as think about how you can make things easier for the user. Hiding options behind menus is great on a phone when you don't have a ton of screen real estate, but is unnecessary when you get to a wider and larger screen. Your brand will dictate what's best in these situations, so it's hard to give very prescriptive advice, but let's look at a bit of a chat app. So the chat app here clearly moves to something like a chat detail view. So you can see your chat list on the left, as well as possibly some description or the last message in that thread, as well as having the main chat that you're looking at as full screen in the middle. Now, when your screen gets very large, you could even pull some stuff out to a third column, whether it's like different interactive elements that you and the person you're chatting with can do, or even just options for the current chat that you're looking at. And you should also think about new experiences that are available for foldables and hinge devices. These devices bring a new opportunity for experiences, as some of the devices support different states of the device angles and that you can react to. And so an example here is a video watching application, where when the device is folded at a 45 to 90 degree angle, you can display video content on the top half of the display, so it's very easy to look at for the user, while having controls and maybe playback options on the bottom half. You can also see this in things like photo editing or video editing apps, where you can have the timelines and other editing options on the bottom half, while the video or photo that you're editing is very easy to see and look at all the changes that you're making. You can handle this with the Jetpack window manager library that we released this year. In this image, you can see how Duo is splitting their video call on it to make it easier to use for users to just put their phone on the desk and easily see the person they're chatting to. And you can check out our intro blog post for more information on the library and how to use it. Multi-window brings in certain challenges as an app developer, and one of them being activity life cycles. In Android 10, we brought in the concept of multi-resume. All apps in this multi-window state are now in a resume state, so content will continue to play or update. This does bring in a challenge for certain applications that use exclusive resources, such as the camera and microphone, as you may have multiple apps visible and in a resume state that are trying to access these at the same time. To handle this, we added a new top resumed activity callback. You would use this callback to try and grab the camera and microphone when you are the top resumed activity, and knowing that you are going to have access to these. You also will find out when you're no longer the top resumed, and so you should gracefully handle losing the microphone or camera access. Being non-resizable does not guarantee you these resources, as there may be a floating activity on top of you that has access to these. Drag and drop is a way that you can bring a really optimized and native experience to your application on these sorts of devices. When screens get bigger, people are using apps in multi-window substantially more often, and they're looking to be much more efficient, whether it's dragging images from a web browser or from a photo editing app into a chat message, or quickly dragging a restaurant name to share with some of their friends. It's a way to really give a native and an awesome experience to your users. And we're seeing it try to be used more and more as the devices get larger. One of the next things to think about and consider when looking at your app's experience on these devices is how you handle different input mediums. And the first thing to realize is that mouse and keyboard are now first-class input mediums on a lot of these devices. Chrome OS devices natively ship with a mouse and keyboard, as well as some of the other desktop platforms that OEMs have created. People are going to be using your app with a mouse and keyboard and expect it to work. Some of these devices may not even ship with a touchscreen, or they may not be using your app on a monitor or display that offers touch. So making sure that things work out of the box is really important. Your list should be able to scroll with a mouse. People should be able to navigate through your app in some regards with a keyboard, and making sure that all items are selectable with a trackpad, a mouse, or even a stylus. When you want to talk about optimizing, though, for these input mediums, you should think about supporting the native behavior that people expect. Things such as right-click, hover states, as well as common shortcuts, especially if your app on other platforms support specific shortcuts that users expect to be able to use. Right-click is something that everyone knows how to do and expects things to work with a mouse. So thinking about how you can move your long press options to different context menus based on if people are using your app with touch or mouse is very important. And hover states is something that we find really enhance the app's experience when using a mouse or a trackpad, because it lets users know what is actionable and what is not. So one of the ways that you can test some of the things that we mentioned in this call is by using the new freeform emulator that we announced. So this is a native Android emulator image that has freeform windows on by default. So you don't have to mess around with any of the developer settings. This is going to allow you to easily test things like app continuity, window size changes, and other configuration changes while keeping the same developer workflow that you're used to. And we also wanted to announce the launch of OS.dev, which is our new Chrome OS developer site. This site will have information around optimizing your Android app, as well as the different capabilities that we have to actually natively develop your Android app on Chrome OS and push directly to the container, allowing you to test a lot of these different input methods or resizing changes much easier. Thank you for watching, and I can't wait to see the experiences that you bring.